All right, let's talk Java lists. So you've got a bunch of items to store, and you've got two main choices, array lists and linked lists. Now, on the surface, they look like they do the exact same thing, right? But here's the thing. Under the hood, their internal wiring is completely different. And believe me, picking the wrong one can seriously, seriously slow down your app. So we're going to break down how each one works and, most importantly, figure out when you should use which.
I mean, think about it. Pretty much every app you use, your shopping cart, your Instagram feed, that to-do list you keep meaning to finish, they're all just managing lists of stuff that are constantly changing. Java gives us these two really powerful tools to handle exactly that. But, and this is the key, they're built for totally different jobs. So how in the world do you decide which one to pick?
Okay, so here's our game plan. First, we'll get a quick look at these dynamic duos. Then, we'll properly meet the array list, and after that, the linked list. Then comes the fun part. We'll throw them into a head-to-head battle to see how they perform. And we'll wrap up by making sure you know exactly how to pick the right tool for the job. Let's get to it. Right, so let's kick things off with what actually makes them similar. At the end of the day, both array list and linked list are here to solve one fundamental problem. How do you manage a list of things that can grow and shrink? I love this analogy. Think of them as two different architects, both tasked with building a house, but they have completely different blueprints. And what's kind of wild is that when you're actually writing the code, they can look identical. I mean, they both implement Java's list interface, which means you're using the same methods, .add, .remove, on either one. The critical difference, and really this is the whole point, is what's happening behind the scenes when you make those calls. That's where everything changes. All right, first up, the one you're going to see pretty much everywhere, the array list. I like to call this one the indexer. Just picture a perfectly organized library shelf. Every single book has its own specific numbered spot. Nice, orderly, and direct. So at its very core, an array list is really just a fancy, resizable array. What does that mean? It means all your data is stored right next to each other, side by side in one big chunk of the computer's memory. The locker analogy is perfect. It's a row of lockers, each one with a number, its index, starting from 0. And this very structure, well, it has some huge implications for performance. So here's the big payoff for that super organized structure. Getting an item is unbelievably fast. If you need, say, the 500th item in your list, the array list is a quick bit of math and boom, it jumps directly to that spot. No searching needed. But, and this is a big but, this beautiful, neat organization creates a massive headache when you want to remove something from the middle. Suddenly, you've got an empty locker just sitting there. And this right here shows you the hidden cost. So you take out an item, let's say at index 2. Now there's an empty space. To keep that perfect, contiguous row of lockers, what does the array list have to do? It has to take every single item after that spot and shift it one position to the left to close the gap. Now, for a list with 10 items, no big deal. But for a list with 1,000,000 items, that is a ton of shuffling, and it can be painfully slow. And when you look at the code, it's so clean, right? It looks totally harmless. You make a new array list, you add a name like Alex, you remove something by its index. It's super easy to write. But now you know the secret. You know about that potential shifting nightmare that's happening just under the surface. Okay, so that's the array list. Now let's completely flip the script and meet its total opposite. This is the linked list, and I like to call it the connector. Forget about that rigid, numbered shelf. Instead, I want you to picture a train. Each car is connected, but only to the car right in front of it and the one right behind it. See, a linked list doesn't care about storing things side by side in memory. They could be anywhere. Instead, every item you add gets wrapped up in this little package called a node. And each node holds just two things. First, your actual data, like a person's name, and second, a pointer. Think of a pointer as just a little note that says, the next item is over there, giving the address of the next node. It's literally a chain of connections. And this completely flips the performance profile on its head. Remember how fast the array list was at getting an item? Well, with a linked list, not so much. If you want that 500th item, you have no choice. You have to start at the very beginning, at the engine of the train, and follow the links from one car to the next 499 times. It can be super slow. But removing an item, oh, this is where the linked list is an absolute superstar. It's crazy fast. And just look at how clever this is. To remove a train car from the middle, you don't have to move the rest of the train. No way. You just go to the car before it and tell it to uncouple.
Then you tell it to couple directly to the car that was after the one you're removing. You just reroute the connection, and that middle car is instantly bypassed. No shuffling, no massive effort. It's beautiful.
And once again, the code itself looks deceptively simple. Very similar to before. You create your new linked list, you add your stops, and you can remove them. And you'll see special methods like remove first method. These are hyper-efficient in a linked list because the list always knows exactly where the first node is. There's no searching involved at all. Okay, so we've met our two contenders, the indexer and the connector. Now it's time for the main event, the head-to-head battle. Let's put them under pressure and see how they really stack up when it comes to the most common things you'd actually do with a list.
And this table really tells the whole story. Let's break it down. For accessing an item, that's the get operation, ArrayList is the undisputed champion. It's O of 1, which basically means it's instantaneous, no matter how big the list is. Linked list, on the other hand, is O of N, meaning it gets slower the more items you have. But look at adding or removing from the middle. The rules are completely reversed. Linked list is a blazing fast O of 1 because of that relinking trick, while ArrayList, it's stuck with that slow O of N shifting operation. This right here, this is the fundamental trade-off. Do you need fast access, or do you need fast changes?
Which brings us to the million-dollar question, which one should you actually use in your code? And the answer isn't that one is better than the other. It's never about that. It's about picking the right tool for the specific job you have in front of you. Here's the deal. You should probably reach for an array list most of the time. Seriously, if your main job is just reading data, you're looping through it a lot, you're grabbing elements by their specific index, ArrayList is your champion, hands down. And if you're not doing a lot of adding or removing from the middle, it's absolutely the way to go. Honestly, you should think of ArrayList as your default, go-to list. So when do you call in the specialist? You grab a linked list for one main reason, when your code is doing a ton of adding and removing. If you find yourself constantly inserting or deleting items, especially anywhere other than the very end of the list, that's your trigger. That's when you need that super efficient relinking that linked list offers. It's the perfect choice when the speed of your changes is way more important than the speed of just looking things up.
And there you have it. That's the breakdown. The indexer versus the connector. One is a master of fast, direct access, while the other is a master of flexible, fast modifications. They are two totally different solutions to the same core problem, and knowing when to pull each one out of your toolbox is a huge skill for any developer. So the next time you start typing new list, which tool are you going to build with?